Hello and welcome to part 4 of the Corn and Soil Health Project's virtual field day series. This video builds on the 3 previous field days considering soil nitrogen tests and shares results from our own farm research that considers whether PAM and PMN work as alternative soil tests. Binod Gimire is a PhD student at the University of Illinois, and he's working to understand how dynamic soil properties, those are properties that are influenced by management, can influence corn performance. Part of his research is being carried out at on-farm locations in Illinois, Indiana, and Wisconsin. Binod is interested in how soil organic matter contributes to plant productivity directly by supplying nitrogen and indirectly by improving soil water holding capacity and promoting crop health. Binod is interested in soil organic matter and other measures of biologically based fertility because standard chemically based soil fertility tests typically used by growers don't always translate well to organic or regenerative farms. This is because they miss biological and physical feedbacks that result from changes in soil organic matter quantity and quality. Fractions or components of soil organic matter can provide better insight into those changes in quantity and quality compared to measures of total soil organic matter for 2 reasons. First, total soil organic matter levels change slowly over hundreds of years and are significantly influenced by climate and texture, which are both outside of our control. Second, the components of soil organic matter that can measure change more quickly, this would be change in terms of years, months, or days depending on the soil organic matter component, can be related to both management practices and things like plant response or reduced erosion. We consider these dynamic fractions of soil organic matter to be good indicators of biologically based fertility. One of these indicators is particular organic matter, or PAM, which is composed of easily decomposed organic matter. PAM has been positively correlated with crop uptake of soil nitrogen in well-drained soils. By looking at the percentage of total soil organic carbon found in the PAM fraction, we can assess impacts of recent soil stewardship. Typical soils in row crop systems in this region have 5 to 7% of total soil organic carbon found in the PAM fraction. But in well-managed soils, PAM accounts for 10 to 25% of soil organic carbon. The ratio of carbon to nitrogen in the PAM fraction indicates the quality of PAM and is related to bioavailability and nitrogen mineralization potential. High PAM carbon to nitrogen ratios, generally greater than 20, result from frequent additions of plant residues and are associated with aggregate stability. PAM carbon to nitrogen ratios rarely exceed 25, which is a value associated with aged plant residues that have low nitrogen contents and can cause N-immobilization. Low PAM carbon to nitrogen ratios, on the other hand, are a sign that energy stocks needed to support below ground food webs are low. Values ranging from 12 to 20, and some others may argue 10 to 25, indicate soils that are well managed. Binod has summarized results from 25 organic farms sampled before corn was planted by grouping them into 3 organic matter categories shown on the left side of the table. So you see low, medium, and high classes that were separated using organic carbon concentrations shown in parentheses below the category label. SOC concentrations in the second column could be converted to total soil organic matter by dividing the value by 10 and multiplying it by 2. If you're interested in this conversion, please check out the resource on the link below. The majority of the fields that were sampled fell into the low and medium soil organic matter classes. Then we observed higher concentrations of PAM carbon in fields with medium and high soil organic matter, which is consistent with the idea that clay abundance contributes to physical protection of soil organic matter, including PAM from decay. When we look at the PAM carbon to nitrogen ratios, we observed that all fell within the proposed optimal range. Of potentially more interest is that we found the proportion of soil organic carbon in PAM carbon higher in the low and medium soil organic matter classes. Also, values in the high soil organic matter class fell below our proposed optimum of 10 to 25%. The percent of carbon in PAM also seemed to be a better predictor of corn yield than either PAM abundance or the PAM carbon to nitrogen ratio. Another indicator that we are looking at is potentially mineralizable nitrogen, which estimates the amount of organic nitrogen that can be readily converted to plant available nitrogen through microbial breakdown of organic matter. PMN, as a measure, should be predictive of inorganic nitrogen measured in the field during the growing season and under optimal environmental conditions. Because it takes time to carry out this measurement in the lab, it may ultimately be used to validate or improve other quicker or cheaper methods for alternative soil testing that are under consideration. And earlier episodes discussed some of these alternatives. While no optimum range or standardized interpretation has been established for PMN, we used typical values observed for surface soils in the Midwest to set a minimum threshold of 25 to 30 milligrams of ammonium nitrogen per kilogram of soil. This is based on N supply for crop growth. If we also consider environmental cost for excess nitrogen, we will want to set an upper limit for PMN as well. Here are the results for PMN summarized again for the low, medium, and high soil organic matter categories. The second column shows total nitrogen, which represents the large amount of nitrogen held in soils and that can be mineralized by microbes. The concentrations of observed PMN are all higher than average values set for our threshold. Based on PMN concentrations, we estimate that in average, fields in this project can supply about 140 pounds of nitrogen per acre, which approaches the 152 pounds of nitrogen per acre that are required by a typical corn crop. Unlike the trend shown for the percent PAM carbon over SOC, in this case the average corn yields were greatest where the percent of total nitrogen in PMN was lowest. This is consistent with the idea that other factors other than nitrogen supply, factors such as plant available water or drainage, need to be measured to understand how soil organic matter influences yield. Future work in BNUT's project will include consultation with collaborating farmers, as shown here, and more data collection and analysis. If you are interested in this topic, we encourage you to check out the article on indicators of biologically based fertility for organic grain systems that will be made available in the eOrganic website. Thank you for your attention.